Hello students, welcome to C Programming. Myself Sarvesh Kumar Soni, Assistant Professor PSIT Kanpur, and this is affiliated to AKTU Lucknow. Today I am going to teach searching techniques. So there are two types of searching. Number one, linear search and binary search. So first of all I am going to discuss linear search. What is linear search? So in linear search we actually search the particular element in the given sequence of list one by one starting from beginning position. So this is a very simple searching algorithm. Element can be stored in any random order. Random order means sorting is not required. If it is already sorted, then it's okay, but if it is not, then it is not compulsory. Element can be stored in any random order. So in this type of search, a sequential search is made over all the items one by one, starting from first position of the array till the end, or when we found that element. So every time an item is checked, and if it is matched with the element stored at the given position, then we return the index where we found it. Otherwise the search continue till the end of the data list, or you can say array. So here the worst case complexity, or you can say average case complexity, will be on the order of n, right? So where n is number of elements stored in the array. So let's explain these linear searching techniques by a suitable example. So here I have an array where various elements are stored in any random order as shown in this figure: 4, 21, 36, 14, 62 and so on. So notice that this is not a sorted array. Elements are in any random order. Okay, so let's say the array name is small a. Okay, so these are the indices 1, 2, 3, 4, 5, 6 up to 12. So actually there are 13 elements in this array a. Okay, and the item which is looking for is 14. I am searching 14 in this array. So I will start searching from beginning index, from 1th index, or you can say it will be actually 0, but I am showing that this is first one index. Then start searching from here. So first of all I will look 14 at this position, but it is a mismatch. Here 4 is stored. Then next I will search in next position, again mismatch. Here 21 is stored. Then I plus plus, that is the increment value of index, and search in next position. So here 36 is stored, again it is mismatch. Now come to the next location. So at 4th index of the array a, I got the element which we are looking for, that is 14. So I will return this index where I got this value 14. Okay, and stop searching further. So this is the simple idea of linear searching, right? So if we talk about the program of linear search, first of all include the header file, then start main function. Then I have declared an array, and the array name is arr, and the size of this array is 20. N variable is taken for number of elements, and I variable is used for looping purpose, right? Key variable will be used for storing the value, that is the item which will be searched, and found variable which is initialized by 0, and this variable basically used to search whether it is successful search or unsuccessful search. That is, if we got the element in the given array, then found value will be reset by 1, and if we search whole array but we did not found did not find that element, then found value will be still 0. So it shows that element does not exist. Okay, so let's begin. Let's start further. First of all, I have to input the number of elements n value. Okay, so scanf the n value and stored in n variable. How many elements you are going to input in the array? So maximum we can give 20, because my array size is 20. So you can increase or decrease the size of this array as per requirement. Okay, now after that I will input array elements and stored by using single loop. So for I equal to 0 to I less than n I plus plus scanf %d because I'm going to store integer value, so format specifier will be %d and store this value at end of arr at I, that is store the value in the array arr at ith index and the retrieve the address by using ampersand operator. So by this single loop I will finally store the value which are given from keyboard in the array, and that value can be in any random order. It is not necessarily to be sorted. So after that I will input the value of key that you want to search. So just write down the message inside printf and scanf %d and key. So I will get the key value. Now for linear searching, just start a loop and start counter from I equal to 0 to I less than n I plus plus, and inside this loop there will be only one condition. If arr at I, that is if we got the element at ith index of the array arr, that means arr at I equal to key, then we will announce a successful search and print the index of that key value. So key exists at this index, print the value of I over here at %d. Okay, and reset the value of found. Initially found is 0, but when we got the value, then we reset this found value by 1 and stop searching further. So we will use break statement after this. Okay, so break statement will terminate the loop and we will come outside of this for loop. But there is one another condition. After this loop, if we search all the elements in the array, but we did not get the values, we did not get the key which I am looking for, then still found value will be 0. So if found value is still 0, it means key does not exist in my array. So this is the overall program, and if we execute this program, then we will get the output like this. First of all, enter the number of elements. Suppose I have entered 7, then another message will be shown here, enter 7 elements. So I have entered 7 elements, 2, 5, 4, 12, 8, 23 and 6, and after that another message, enter the item that you want to search, and suppose I have entered 23. So when we press enter, then we will get a resulting message as 23 exists at index 5. Okay, so as you can see, 23 is present as 5th index, 0, 1, 2, 3, 4, 5, right? So 23 is present at 5th index. So this will be a successful search. So this is the linear searching. Now come to another searching technique, that is binary searching, right? So this is a better technique than linear search. So it is faster algorithm with runtime complexity of on the order of log n base 2. Okay, so it is more faster than linear search. How? I will discuss further. For this algorithm, the data, that is the array, must be sorted. Okay, either in ascending order or in descending order. But in this example which I am teaching, in this example I am considering the array must be sorted in ascending order, right? So binary search looks for a particular key by comparing the middle item of the array. Every time we will partition the array into two equal half and we will search the item at the middle position of the array. Okay. If match occur, then announces a successful search and return the index. If the middle item is greater than the key, where key is the item, key is the value that is going to be searched in the array. So if the middle item, which is currently at the middle position of the array, it is greater than my key, then key is searched in the left half, because my key is lesser than, so it is the possibility that key may exist in left half of the array. Okay, so I will further search in left half of the array, skip the right half. But in reverse, if my item, if my key is larger than the middle position element, then we will search further in the right half of the array. So this process will continue on the sub arrays as well until the size of the sub array reduces to 0 or we got the element. So in this diagram I am explaining this binary search technique clearly. Let's consider this array 4, 7, 8, 10, 14, 21, 22, 36, 62, 77, 81, 92. Notice that these are the elements which are already sorted in ascending order. So if array is not sorted, then binary search will not work. This is the mandatory condition for binary search. So here my array is already sorted in ascending order, then it is okay. So let's say starting index is 1 and last index is 12. Okay, so I will consider three variables of integer type in this program. So these are the variables named as first, mid and last. So initially we set first variable to the beginning of the array at 1th index. Okay, and the last variable will be at last position of the array, that is 12th index. Okay, now mid value will be computed at computed by this formula. Mid will be equal to first plus last by 2. Every time we will find new mid position by this formula, first plus last by 2. Okay, so let's say I am looking for 22. My target key is 22. मैं 22 को ढूंढ रहा हूँ इस array में. Okay, so first of all I will find out the mid value. So mid value will be equal to first plus last by 2. First is 1, last is 12. So 1 plus 12, that is 13. 13 by 2, 30 by 2 will be 6.5, right? But I will consider only integer value because all are integer variables. So mid value will be 6. First plus last by 2, 6. Okay, so I will search the target key, that is 22, at this middle index, 6th index, A6, but at A6 there is 21. Okay, so mismatch occur, नहीं मिला मुझे जो हम ढूंढ रहे हैं, that is 22 is not present at this middle index. Okay, so again I will check further conditions whether my key value is larger than or lesser than this middle position value. Okay, so my key is 22. 22 is larger than this middle value 21. Okay, so again the search will be made in right half of the array. Okay, because मेरी की बड़ी है तो कहाँ मिलने की संभावना है, उसकी राइट हाफ में मिलने की संभावना है. So I will search in right half the array, left half will be skipped. Okay, now in next step I will search from here to here, that is 7th index to 12th index of the array A. Okay, so what to do? First of all, we have to reset this first value. So first value initially was 1, but now first value becomes 7. Okay, so what to do? Just write down first equal to mid plus 1. So mid value will be 6. So my first variable will be reset to mid plus 1, that is 7, and last value is still 12. So for right half, this will be the condition. First value should be mid plus 1, but last value will be unchanged. So from 7th index to 12th index, I will search further the key value. Okay, so again I will find out the new mid value. So new mid value will be 7 plus 12 by 2, first plus last by 2. So 19 by 2, 19 by 2 is 9. Okay, so this is the new mid position, but here 62 is stored, but I am looking for 22. So again mismatch occur. Okay, so again we will check for the two condition whether my key is lesser than or larger than this middle value. So my 22 is lesser than 62. Okay, so the possibility that my key exists in left half of this subarray. So for left half of this subarray, we have to reset the last index. Okay, now last index is 12, but after this my last index will be changed by 8, that is mid minus 1. Mid is 9, so last value will be reset to this position. Okay, so I will write down in program for this condition, I will write down last equal to mid minus 1 for left half searching. Okay, so first value is still 7. Okay, as I am looking, फर्स्ट वैल्यू अभी भी 7 ही है, लास्ट वैल्यू चेंज होके 8 हो गई, पहले ये 12 थी, राइट. सो अगेन आई हैव टू सर्च इन दिस पार्ट ओनली. ठीक है, नाउ अगेन वी विल फाइंड आउट न्यू मोड पोजीशन. सो फर्स्ट प्लस लास्ट बाई 2, दैट इज 7 प्लस 8 by 2, that is 15 by 2. 15 by 2 is 7. So at 7th index I will search further. So at 7th index I got 22. Okay, so 22 is equal to 22, so I will announce a successful search. So finally I will return this 7th index, that is the index where I got my key. Okay, so this will be a successful search. But if the situation which is explained in this slide, I am looking for 11. Okay, so as shown in this figure, there is no value 11 stored in this array. So what will be the final answer? It will be unsuccessful search. Okay, क्या करेंगे हम? वही again procedure, mid first plus last by 2, that is 1 plus 12 by 2. So middle index will be 6. So 6 इंडेक्स पर क्या पड़ा है 21, बट हमें क्या फाइंड आउट करना है 11. सो मिसमैच अकर. सो फर्दर आई विल चेक वेदर इट इज लेसर देन और लार्जर देन द मिडिल वैल्यू. सो 11 इज लेसर देन, तो पॉसिबिलिटी कहाँ है लेफ्ट हाफ में मिलने की. तो मैं क्या रीसेट करूँगा, लास्ट वैल्यू विल बी रीसेट टू मिड माइनस 1. ओके, सो अगेन लास्ट वैल्यू बिकम 5, मिड माइनस 1, 6 minus 1, that is 5. ओके, so this is the left half of the array. यहाँ मिलने की संभावना है मेरा 11. okay, so again I will find out the mid value, that will be first plus last by 2, that is 3. So at third index it is 8, but I am looking for 11. So 11 is not present, mismatch occur. So whether it is in left half or right half, so it is in right half because my key value, that is 11, is already larger than this middle value. So I will search further in right half of this sub array. Okay, so for right half I have explained we have to reset the first by mid plus 1. So first will be reset by 4, mid and last is still 5. So 4 plus 5 by 2, that is the mid value. So mid value is 4. in this case. So I am looking at fourth index. So here 10 is stored, but हमें क्या चाहिए 11. So 11 is not present. Okay, so 11 is already larger. It means I have to search in right half, because 11 is larger than this middle index value, that is 10. So I will look further in this place. Okay, so मैं जैसा देख रहा हूँ यहाँ पे केवल एक ही वैल्यू बची है, ओनली वन सेल टू बी सर्च्ड. ठीक है, सो फर्स्ट वैल्यू क्या होगी? फर्स्ट वैल्यू मिड प्लस वन. ओके, सो मिड प्लस वन, मिड वाज 4. So first value will be 5, mid plus 1. Last value is still 5 as it was in previous case. So 5 plus 5 by 2, that will be the middle value, and it comes out to be 5 also. Okay, so at fifth index I am looking, but it is 14, but I am looking for 11. So मैंने एरे की लास्ट पोजीशन तक देख लिया. ओके, और इसके बाद अब मेरा जो वैल्यू है, क्योंकि 11 इज लेस देन क्या है 14. ठीक है, तो कहाँ पॉसिबिलिटी? लेफ्ट हाफ में. सो अकॉर्डिंग टू लेफ्ट हाफ कंडीशन आई विल रीसेट द वैल्यू ऑफ लास्ट बाय मिड माइनस 1. सो लास्ट वैल्यू बिकम 4. सो दिस विल बी द फाइनल सिचुएशन. फर्स्ट इज 5, लास्ट इज 4. ओके, सो दिस इज द ओवरफ्लो कंडीशन. दैट इज अब कोई एलिमेंट बचा ही नहीं सर्च करने के लिए. मैंने लास्ट इंडेक्स तक, लास्ट वैल्यू तक मैंने फाइंड आउट कर लिया है, बट कभी भी मेरी कंडीशन ट्रू नहीं हुई. इसका मतलब जो हम सर्च कर रहे हैं वो हमारे एरे में प्रेजेंट नहीं है. राइट, सो दिस इज एन अनसक्सेसफुल सर्च. ठीक है. ओके, नाउ कम टू द प्रोग्राम ऑफ दिस बाइनरी सर्च. फर्स्ट ऑफ ऑल इंक्लूड द हेडर फाइल stdio start main function, and I have taken an array ARR of size 100. It means maximum we can store 100 elements in the array, but condition is that those elements must be in sorted order, in ascending order in this case. So n variable is declared for number of elements. कितने हमें elements store करने हैं? maximum हम 100 कर सकते हैं. I variable is used for looping purpose. Key variable जिसमें हम store करेंगे क्या हमें search करना है. ओके, फर्स्ट, लास्ट, मिड जो मैंने एक्सप्लेन किया है लास्ट स्लाइड में. एंड फाउंड वैल्यू बेसिकली यूज फॉर वैलिडिटी पर्पस, कि जो हम ढूंढ रहे हैं वो हमें मिला या नहीं मिला. ओके, एंड इनिशियली फाउंड इज 0. नाउ फर्स्ट ऑफ ऑल इनपुट द नंबर ऑफ एलिमेंट्स. printf enter the number of element is scanf %d and n. ओके, मैक्सिमम हम कितने पुटअप कर सकते हैं? 100 एलिमेंट्स. तो सपोज मैंने आपसे कहा कि कितने एलिमेंट्स आपको पुटअप करने, आपने कीबोर्ड से इनपुट किया 10. सो इट मीन्स आई वांट टू स्टोर 10 एलिमेंट्स इन माय एरे. ओके, सो आफ्टर दैट आई हैव गिवन अ मैसेज दैट एंटर n एलिमेंट्स इन ascending order. So if n is 10, so the value, the message will be printed enter 10 elements in ascending order. तो मैंने 10 एलिमेंट्स कीबोर्ड से पुटअप कर दिए, बट दोज मस्ट बी इन असेंडिंग ऑर्डर, सॉर्टेड ऑर्डर. तो उनको रीड कर लिया. फॉर i इक्वल टू 0 to i लेस देन n i प्लस प्लस scanf %d and arr at i. ओके, स्टोर every value at ith index of arr array. Okay, so as we can see, I value is changing by this loop starting from 0. So all the elements will be stored in the ARR array one by one. After that I have to input the key value जो हमें सर्च करना है. So वो हम scanf करा लेंगे, scanf %d and key. Okay, now start the binary search technique. So first value will be start to 0. Okay, beginning पर हम beginning index पर हम इनिशियलाइज करेंगे फर्स्ट वेरिएबल को, एंड लास्ट वेरिएबल कहाँ पे होगा? लास्ट इंडेक्स पे, दैट इज n-1th इंडेक्स पर. ओके, स्टार्ट द लूप. सो व्हाइल फर्स्ट इज लेस देन और इक्वल टू लास्ट. ओके, मैं ऑलरेडी प्रीवियस स्लाइड में बता चुका हूँ व्हाट इज द ओवरलैपिंग कंडीशन. सो दिस इज द ओवरलैपिंग कंडीशन. जब तक फर्स्ट इज लेस देन और इक्वल टू लास्ट है, ओके, टिल सिंगल एलिमेंट इन द एरे. तब तक हम फर्दर सर्च करते रहेंगे. ओके, so every time we will find out the middle value by this formula first plus last by 2. Okay, and there will be 3 condition. तो फर्स्ट कंडीशन इज मैचिंग कंडीशन. जब हमारा जो की है जो हम सर्च कर रहे हैं वो मिडिल इंडेक्स पर प्रेजेंट है, मिल गई है की. ठीक है. सो फर्स्ट कंडीशन, इफ की इक्वल टू ARR एट मिडिल इंडेक्स, then I will announce a successful search and print the element found at index. Which index? Mid value will be printed over here. Okay, after that मैं क्या करूँगा, found को reset कर दूंगा. तो found initially was false or you can say 0, now it becomes true 1. found मतलब एलिमेंट हमें मिल चुका है जो हम सर्च कर रहे हैं, तो फाउंड को रीसेट कर दिया बाई 1. एंड फर्दर सर्चिंग नहीं करेंगे, दैट्स वाई मैंने क्या किया है, इसी पोजीशन पे हमने रोक दिया है फर्दर सर्चिंग को. तो ब्रेक कर दिया, ब्रेक हमारे लूप को टर्मिनेट कर देगा. ओके, सो दिस इज द फर्स्ट इफ कंडीशन. जो हम सर्च कर रहे हैं वो हमें मिला मिडिल इंडेक्स पर. इफ इट इज फॉल्स, इफ दिस कंडीशन इज फॉल्स, सो देयर आर 2 फर्दर पॉसिबिलिटीज. पहले क्या पॉसिबिलिटी है, इफ माई की इज लेस देन द मिडिल इंडेक्स वैल्यू ऑफ द एरे ARR. तो अगर मेरी की छोटी है तो उसके कहाँ मिलने की संभावना है, कहाँ मिलने की पॉसिबिलिटी है, लेफ्ट हाफ में. तो लेफ्ट हाफ के लिए मुझे क्या करना होगा, जस्ट रीसेट द लास्ट वैल्यू. अब मैं लास्ट में को इधर लाना है लेफ्ट हाफ की तरफ. सो दैट विल बी इक्वल टू मिड -1. सो एंड लास्ट कंडीशन अगर ये भी फॉल्स है तो लास्ट कंडीशन क्या बनेगी, ये हमारा एलिमेंट कहाँ मिलेगा, राइट हाफ में. तो राइट हाफ के लिए फर्स्ट को हम इधर शिफ्ट कर देंगे राइट में, दैट इज फर्स्ट विल बी इक्वल टू मिड +1. तो ये प्रोसीजर हमारा वाइल लूप में रिपीट होता रहेगा जब तक हमें एलिमेंट मिल नहीं जाता या हमारी सर्चिंग ओवरफ्लो नहीं हो जाती है. ओके, आफ्टर दैट आई विल सर्च अनदर कंडीशन. इफ फाउंड वैल्यू इज स्टिल 0, इट मीन्स जो हम ढूंढ रहे हैं वो हमारी लिस्ट में प्रेजेंट नहीं है. सो आई विल प्रिंट द एलिमेंट डज नॉट एग्जिस्ट इन द लिस्ट. ओके, सो दिस इज ऑल अबाउट दिस बाइनरी सर्च टेक्निक. सो इफ वी एग्जीक्यूट दिस प्रोग्राम, then I will get the output as shown in this slide. Enter the number of elements. Suppose I have entered 8. Then enter the elements in ascending order. Okay, so I have entered these elements in ascending order. Now after that enter the key that you want to search. So my key is 23. So as we can see that 23 is present, so it will be a successful search and print element found at index 4. Okay, so this is the output. Thank you.